And welcome everybody to the Daily Space Weather. First thing we're looking at today is the solar colorized magnetogram to see three significant sunspot groups. This one's beta class, meaning it's got two opposite polarity umbrae at least. This one's beta class as well. And this one, which actually has the largest umbra of all, is actually only alpha class, having only one polarity associated with its umbra. We'll also be talking about some massive filaments, the possibility for a coronal mass ejection, so a watch is on, as well as galaxy NGC 6544. Here's another full disk view. This is an ionized helium, 304 angstroms. And we've got filaments all over the place, both in the north and southern portion of the Earth-facing disk. You can see some of them down here, and there are a bunch up here in the north as well. Again, likelihood of a coronal mass ejection quite high right now. We've seen some C-class solar flares coming out of especially this sunspot group up here. And here's another full disk image, another full disk video in 94 angstroms, one of the many ionized states of iron, as iron prefers to have a lot of electrons, folks. And next, here's a diagram of the solar system. Keep in mind, this is not to scale, folks. There's where things will be in a week. Looks like about 6 days until the next full moon. Here's a star chart. Feel free to pause the video if you must. The yellow line here is the ecliptic. And if you're up before dawn and you've got a clear sky and a view of the ecliptic, you may see Saturn and Jupiter rising ahead of the sun. The 10.7 centimeter radial flux, the output of the upper chromosphere and lower solar corona, the corona being the sun's atmosphere, at 80 solar flux units. And if you're wondering what a solar flux units is, it is 10,000 joules. Here's a 1-year chart of the radial flux, the black line up top here. So a little increase here in the last few days. The red line down here is the sunspot number, and we're not expecting any geomagnetic storms or anything like that, according to NOAA, over the next 2 or 3 days. Here are the alerts, or lack thereof. KP expected only to get to 3. Let's do an earthquake rundown. We didn't see any major earthquakes over the past 24 hours. Although there was a deep one at Fiji at over 520 kilometers depth. Also some quakes on the west coast of the U.S. Looks like California saw a series of quakes, none particularly large. Pretty much a lull in earthquakes here, folks. Small deep quake in Alaska as well. Earthquake rundown includes Sakurajima, which exploded on the Isle of Kyushu, Japan. It produced an 8,000-foot ash plume. Suwanosejima in the Ryukyu Islands produced a 5,000-foot ash plume as it exploded as well. Mount Ibu on Halmahera, Indonesia, regular discrete volcanic emissions produced a 6,000-foot plume of ash. Luatolo in the Lesser Sunda Islands exploded as well, flight level 080. It's an 8,000-foot ash plume. Semeru exploded, 14,000-foot ash plume on the East Javan, Indonesia island. Dukono exploded, 7,000-foot ash plume. Popocatépetl exploding, 20,000-foot ash plume in central Mexico. Fuego in Guatemala, 15,000-foot ash plume as it explodes. Sangay exploding in Ecuador, 22,000-foot ash plume. Revenador also in Ecuador, exploding, 14,000-foot ash plume there. And Sabancaya is exploding. It's producing a 26,000-foot plume of volcanic ash and reminding us to remind our viewers to not pole vault the caldera. So this particular public service message brought to you at great personal risk and expense by smAshomash.com. And if you'd like to support our efforts, please do head to smAshomash.com. And welcome to the Near Renaissance. One of the links you can find at smAshomash.com would be the smAsho merch link. And if you click on that, you can eventually find the Do Not Pole Vault the Caldera hoodie. And since there's still snow falling over a significant portion of the U.S., we figured it was appropriate. Since it's so hot that it's cold, we figured we'd put up a sweatshirt despite it being April 21st. And I don't know why everybody was so delighted about Hitler's birthday yesterday, but for some reason everybody was super stoked about the fact that it was 420, a.k.a. Hitler's birthday. I don't know what the deal is, but yeah, I hope you had a great Hitler's birthday yesterday. Congratulations. And remember, folks, do not pole vault the caldera. So we did see some solar flaring here. We saw an M-class flare late night on the 19th, but we also saw 2 C-class flares over the past 36 hours. There's the 3-day chart from the GOES 16. The GOES 16's sun-facing instrument suite, the X-ray flux. We don't see any strikes in the proton flux. We show it daily to show you that it's flatlined. No coronal mass ejections have been striking the geospace. Here's the GOES magnetometer over the past 3 days, and we're seeing continued spiky readings here. And we're seeing a continued high-speed coronal hole wind stream. We'll get to it in a moment. First, some National Sunspot Observatory data. It's our Gong 2 section. And there is a North Pole current sheet headed the Earth's way here. You can see that in green. Somewhere about 2 days from now, expecting the Earth to be in a North Pole current sheet. Keep in mind, the magnetic environment can suddenly change, and the data is 1.5 hours old at the time we made the video. Next, the line of sight ecliptic plane field plot. Basically the same thing. It also shows you this blue line, which shows you the extent to which one field or the other is in charge. And when you see the blue line shifted to the north like that, that's an indication that the South Pole current sheet is the one in which the Earth currently lies. And here's the line of sight coronal hole plot. Nothing to write home about there. This shows the sun's B field in blue. And here's the detected filaments and detected sunspot groups. 2817 in the upper right there, still beta class. Likelihood for additional significant solar flares and coronal mass ejection still there, folks. And that's the most likely spot to see a coronal mass ejection come from, around the area associated with sunspot 2817. This one up here. 2816, still beta class, still significant, although it is in the Earth-facing zone, causing the likelihood of solar flares from 2816 to be slightly lower, and sunspot 2018 is only an alpha class sunspot. No real chance of major flares from that. And over on the left you can see those filaments, quite a few in the north as well as on the east. There are some in the south as well that aren't quite showing up. They are down around this area. And let's continue on. The KP index currently at 3, a result of that high-speed coronal hole wind stream still coming in. Quite a significant coronal hole wind stream. And we've seen the speed drop down to about 550 kilometers per second. Current solar wind density, 6.21 protons per cubic centimeter. Current solar wind speed, 552 kilometers a second. Still enhanced from that coronal hole. Here is the magnetohydrodynamic pressure in nanopascals. It's 4 hours of data. We show it daily If you're wondering what was happening 2 years ago on this day, go back and watch our daily space weather video. We probably showed 4 hours of data in 2019 on April 21st. Here is the geospace magnetic perturbations on the ground. Geospace delta B being changes in the Earth's B field, this one in nanotesla. And like the last geospace magnetosphere movie, this is all based on the space weather modeling framework. During this geomagnetic excursion. Now we do stream live to Twitch. We've got 3 major spots that we put our videos, folks. Twitch.tv/smAsho, youtube.com/smAsho, and bitshoot.com/smAsho. Thanks to our Twitch followers. And let's take a moment to welcome our Twitch followers as we've gone live for the brief cosmology segment for today. Again, if you view the content on BitChute, don't forget to leave us a comment. Tell your friends and foes about us over there. Thanks to our new subscribers over on BitChute. Most of all, don't forget to press like and subscribe on YouTube. Don't forget to check out our playlists, youtube.com/smashamash/playlists. There's lots of content besides the daily space weather videos, so check it out. And this is today's cosmology segment. First thing we'd like to talk about is Centaurus A. So Centaurus A is an interesting composite galaxy indeed. And you may see some chaotic structures within that galaxy, some dust lanes and some rather irregular looking features. We can also see an apparent jet coming out of the galactic core in this sort of a fashion. And you can see something similar to the Milky Way galaxy's Fermi bubbles out here. And what you're looking at here is it's a composite image. So we've got various different observatories looking at this. And what you're looking at here are, so the ESO is visible. That's the white colored portion. The apex, which is a 747. No, that's the Sophia, rather. So the apex would be orange, Chandra is blue, Spitzer is red, that's infrared light. And I would note that the magnetic field lines are actually parallel to the dust lanes on the outside of the galaxy and distorted near the center. So this is believed to be a recent galactic merger, which is why the center portion, the main disk of the galaxy, looks quite distorted here. Great view there of Centaurus A. This is the APOD, the astronomy picture of the day. You can go check it out yourself at apod.nasa.gov. Today's featured astronomy picture of the day of Centaurus A. Today we're not going to pick any random numbers. We're going to look at NGC 6544. Now, this particular globular cluster in the new general catalog, entry number 6554, is located actually quite close to the galactic disk, the galactic plane of the Milky Way. And if we zoom way in, again, this is located at about 8,000 light years. And you'll find a recent article in phys.org about NGC 6544, this globular cluster. And basically what the article is about is the chemical composition. So the metallicity was interesting, the aluminum to iron ratio. They did a chemical study of 23 of the stars, I believe the ones in that rectangle there. So perhaps have a read on this if you like. It's in phys.org's Astronomy and Space section. The research found that the analyzed red giant branch stars have mean metallicity of about negative 1.44 and alpha element abundances at levels 0.2. When it comes to the asymptotic giant branch stars, these values were measured to be negative 1.66 and 0.25 respectively. According to research, 14 out of the 23 investigated stars showcase distinct chemical patterns, which indicates they are so-called second-generation stars. In general, multiple populations within globular clusters refer basically to a first generation and second generation of stars. Studies show that first generation stars pollute second generation with processed material, creating different subpopulations in globular clusters. The composition of the second generation stars varies almost at an individual cluster level. And one of the main issues we're talking about here is the aluminum to iron ratio. So metallicity is very important in the chemical structures in the realm of cosmology. And that's pretty much all I have to say about that. And that's today's cosmology segment. Thanks for tuning in, folks. We'll have to say goodbye to Twitch. We'll bring you back for the meteorology segment. Next, we'll look at electrons. The Earth is surrounded by them, and we're seeing very high levels again, getting up to about 14 times warning levels. As you can see here, very high levels of electron flux. We're expecting major GPS errors. Here's the forecast model, and we're expecting similar levels here over the next couple of days. I would tend to agree with that forecast, as we tend to see high levels of electron flux following coronal hole wind streams. And this currently slowly waning coronal hole wind stream has been a powerful one. Here's a diagram of the atmosphere going way out to the Van Allen belts. Feel free to pause the video. Here's a visualization of the total electron content. And you can see very high levels of electron flux here, especially just north of the equator around noon. And we're also seeing some chaotic belts here despite seeing high levels of electron flux. So as that coronal hole wind stream takes its good old time subsiding, expect to see major GPS errors once again around the equator, especially at noontime, although some at nighttime as well there, as you can see from the visualization. Here's another diagram of the atmosphere. We show this daily to show you where the F layer is. That F right there, that's the F ionosphere layer located at about 300 kilometers of altitude. And here's a visualization of that. You're looking at vibrational frequency here, measured in millions of vibrations per second, otherwise known as megahertz. And ionosphere looking fairly normal here. And just give it a moment to play through. Each tick of the clock here is 15 minutes, folks. And let's move forward to the latest image. Latest image coming through at 9 o'clock Universal Time. Looking normal there. And now it's time to do some meteorology stuff. So let's welcome back Twitch. Welcome back, Twitch, to the Smash News Network. Least busted name in news. Here are the jet streams of the eastern world. And this cyclonic system here taking its good old time moving up north from the Philippines. Here are the surface winds, and we still see significant winds associated with that. In fact, it's actually increased a little bit, it looks like. Let's zoom in real quick. See if we can get a high wind reading here. Actually, winds have reduced a little bit. So this has weakened a little bit here, folks. We still do see a jet stream level counterclockwise rotation, but not a clockwise rotation. An indication it's looking pretty steady here. Here are the jet streams of the western world. And we've got some funky winds in the North Atlantic as well. We'll show you the surface winds. And there you can see these chaotic wind patterns once again in the North Atlantic, all the way from Bermuda to Iceland. And that very powerful low that was hanging out off of Cape Cod has finally moved up north. It's about due south of Greenland now. Powerful counterclockwise rotation there, indicating a low pressure system. And there's the jet stream once again. Next, lightningmaps.org. We're looking at a real-time lightning map. I use lightningmaps.org when I hear thunder. No terrestrial lightning to report on right now, but there is the global lightning scenario. And let's talk about snow. Apparently it's so hot that it's cold, folks. Oh my God, we better reduce the carbon dioxide because carbon dioxide totally has something to do with climate, right? Leave us a comment. Let us know what you think about carbon dioxide in the climate. Anyway, looks like the entire state of Ohio is covered with snow. And it's April 21st. Let's advance this to the Euro forecast. Here's where we expect things to be at 2 p.m. tomorrow. A large portion of the Great Lakes region and New England remain covered in snow, as well as most of the Rockies. So it's 4 winters in a row of record snowfall across the Northern Hemisphere. And check out the freeze warnings. We're on weather.gov. And look at the freeze warnings. Absolutely insane. April 21st. Freeze warnings over about 1/3 of the country here. The entire central portion of the country, including places like northern Texas. Even some hard freeze warnings there in the Texas Stovepipe, the Oklahoma Panhandle, eastern New Mexico. Apparently it's so hot that it's cold, folks. Oh my God, we better make the planet cooler by firing rockets into the atmosphere and spraying particulates in the stratosphere a la volcanic activity. Great idea. Here's the U.S. Doppler radar map. Geoengineering, one of the most idiotic ideas in the history of mankind. In fact, geoengineering is almost as idiotic as carbon sequestration. I used to think Elon Musk was smart. Now he's offering $100 million for the best carbon dioxide sequestration process. An absolutely moronic thing to do. And we cite lots of moronic things here at the Smash News Network. Least busted name in news. Check out the heavy snow here, sweeping across Ohio, Tennessee, Kentucky, about to make it into Pennsylvania, New York, West Virginia. Significant snow here once again over the central part of the U.S. Yowzers, it's so hot that it's cold. Here's what's going on in the cloud layer. And here's the water vapor map. If your Doppler radar doesn't show you enough information, check out the water vapor map. Water vapor can't hide from the water vapor map. This shows you water vapor that isn't condensed onto clouds. The 3.9 nanometers typically shows you water vapor that is condensed onto clouds. And that's today's meteorology segment. Thanks for tuning in, Twitch viewers. And we'll have to say goodbye to Twitch as we go to our bonus features. Twitch viewers, don't forget to check us out at youtube.com/smAsho. So here come the bonus features at the Smash News Network, least busted name in news. We're completely different than CNN, who is rebranding itself as the Climate Nonsense Network. Anyway, let's look at the latest imagery in hydrogen alpha from El Teide, Spain. Yes, El Teide, Spain. Gotta have it. And you can see major filaments in both the south and the north. Again, likelihood of coronal mass ejections is significant, especially from the northern portion. And I'll just leave it at that. Thanks, Smash Team. Don't forget to share our content on your social media. Tell your friends and foes about the channel, and maybe it will not evaporate overnight. Who knows? And before we complete the video, let's take a look at the colorized magnetogram and solar intensitygram. So here's the colorized magnetogram. Again, 3 sunspot groups. This one is the most likely to produce significant flares, and coronal mass ejections are most likely to come out of someplace out of the northern portion. Here's sunspot 2816, and here's sunspot 2818. And this one up here, 2817, has actually grown in the past day, especially this leading North Pole umbra. Next, I'd like to thank our patrons, the true source of funding for the content. Please consider becoming a patron and increasing the probability that these videos will continue to exist and remain publicly visible. Thanks, patrons. And if you'd like to become a patron to get the earliest alerts, various other media, etc., patreon.com/smAshomash. Last but not least, we've got some more full disk views. Here's 193 angstroms. One of the many UV emission spectral states of ionized iron. And we'll close things out with 171 angstroms. Thanks again for tuning in, folks. Remember, stare at the sun. Welcome to the Neo-Renaissance, and since it'll never be now again, may that solar wind be at your back.